Scott's Geography Notebook. Did you want to try saying it?
Da, da, da.
When we're looking at groundwater, what we're going to be looking at is the water that might land on the surface as precipitation or as irrigation, and it starts to infiltrate its way through. We call this process percolation or infiltration, and eventually it's going to start to fill in everything. Now, before we get too far, I want to take just a moment and show you guys a little video about what this groundwater really looks like if we were down there. Be right back. When I was growing up, they would talk about these groundwater reservoirs, and I just assumed that a reservoir was a big old underground lake or something, that there was like big caverns or tunnels or volcanic caves where all the water would settle. Turns out it's not really the case. What it is just the soil starts, or the dirt, whatever's down there, starts to get filled in with water. And so we have our aquarium gravel, and as you can tell, all that we have now is the gravel, which represents our soil particles, and air. Okay? Now, once it starts to rain on the top of this, what starts to happen is we start to see that water flowing down through the soil. Now, I made my water blue just so that we could see it. But we get down and we're to a level where we're about there. Now, what do we see? We see that this line right here kind of divides two different areas. Down through here, it's completely saturated. And so we call this zone right in through here the zone of saturation. Clever name. Now this region right in here, that has air mixed in with it. Now it's going to have some water, and it's going to have the soil particles, and it has air. So we call this region right in there our zone of aeration. Now, when you're wanting to pump that water back out, you need to send a pipe down into that water table, send the pipe down, and they drill a hole, and at the bottom of the pipe, there's spots small enough for the water to get in, but not big enough for the soil particles to get through. Then they put a pump down at the bottom of there, pump it back up into a tank, and there you go. Okay, so I hope that helped you understand a little bit more about these different areas. We know that the water is going to be infiltrating or percolating down. As it goes down a little bit lower, it's going to be hitting this impermeable layer. We could call that bedrock. We could call it an impermeable layer. Whatever we want to call it, it's going to be down there where the water is no longer going to be infiltrating down. Now, I made this model, this drawing, really, really simple. We can have all sorts of different layers and other spots like that. So what we have here is our zone of saturation, meaning in here, we're going to have whatever soil particles we had. Soil and water. That's all we've got. Now, just above there, we have our zone of aeration, but they spell it a little bit differently. Aeration. The T-I-O-N. There we go. Zone of aeration. And in the zone of aeration, we're going to have soil, and we're going to have water, but we also have air. Okay. Now that layer in between the two, that is called the water table. Okay. So we have our zone of aeration with soil, water, and air. The air is infiltrated or percolated all the way down through that to our zone of saturation until it can't go any further past the bedrock. Then it starts to fill in, and we have our soil and we have our water. That's groundwater. That's what we build our little wells with a cute little roof on them. Okay, maybe they don't have wishing wells anymore, but we send our pipe down into that water table. And as that video showed you, if you make that bottom so that the water can flow in, but the gravel or sand or dirt or whatever you have doesn't, then you're able to throw your bucket down into the well, or maybe you put an electric pump down there and that pumps your water up and out.